Hello, everyone, and welcome to my presentation, in which I will tell you a story how we built quite a sizable application with ClojureScript as a front end over the course of the last 9 years. And previous presentation was about like a modern ClojureScript. This will be more of a traditional ClojureScript because we have been in production for quite a while, so we cannot kind of pursue a lot of new and shiny tools. But I will tell you how to build it with ClojureScript and Reagent and Reframe. Since this presentation is an experience report, I'd like to first start to describe what kind of application we have built and what kind of specifics networking domain brings to this kind of UI, as well as to give you some idea about the size and complexity of the application. Then I'll give you a short history of how we started with a small prototype, like literally a single screen showing one graph, all the way to production across hundreds of customers. Then I will give you several like highlights of different architectural decisions that we made, as well as show some code examples and some frameworks that we built internally in order to support our code base. And finally, I'll share some lessons learned, both technical as well as organizational. Because as you run this kind of application for quite a long run, there are a lot of things happening on an organizational level. Like people join, people leave, new technologies come, you're getting acquired, etc. So let's get started. Juniper Apstra. So Apstra was a company. It was acquired by Juniper, and coincidentally, the application itself is called Juniper Apstra. And it's a pretty much standard client side for any kind of API that you will see on ClojureScript. So our backend is written in Python and C++ because this is how you write SDK clients for networking devices. But these clients actually exposed REST API and GraphQL API for us. And on the client side, we use pretty standard, old-fashioned set of libraries. Reagent for views, Reframe for state management. And we still do some of the visualization using plain JavaScript because it's easier just to kind of copy JavaScript example and modify it when you have like some specific visualization available on the internet. And again, it's a single-page application, which means that from the end-user perspective, we just kind of send a single div, and the rest of the logic lives in the compiled ClojureScript code. So there are some specifics to our front end. First is that target audience is network architects and network operators. Their main goal is to be able to design and build data center network, be able to deploy it, and collect telemetry data and perform some analytics and data operations. And for UI, it means that A, we will need to fetch a lot of data from multiple sources, and we'll need to glue this data, and B, we need to be able to present it to the user, so they will spend as little time as possible trying to solve the problem. The goal for our application is very similar to the goal of the game of golf. You win if you play it less. So the example that you see here, in order kind of to render this neighbors view, you need to fetch information about nodes in the system, ports, LLDP telemetry to verify that cabling is correct, and some additional data. And this all happens on the client side. Next, there is an underlying complexity of, inherent complexity of an underlying domain, which is networking, which means that every time when we'll be building forms, each form will contain dozens of different node knobs, and behind each node knob, there will be probably 12 different standards and 50 different RFCs that have developed over the last several decades of networking. Finally, we are in a world in which people love specific kind of visualizations, and if you ever will try to see how the network looks like for 200 racks deployment in a real data center, you will see a very long scroller at the bottom that you'll need to drag back and forth. That's why we actually built a 3D visualization as well. So, in terms of application size, we're quite a large application, and not only by Clojure standard, but by any single-page application standard. We have to interact with almost 800 different API endpoints, and we render them on almost like 400 different UI screens. And at this point, we have almost 200 different forms. And the way I calculated this information, I basically found the usages, how we use our router and how we use our forms component. So this data constantly grows. Like every day, we add probably a dozen to each line. Next, in terms of least favorite metric of all developers, lines of code, we're actually recently crossed 100,000 lines of ClojureScript code. And this is an interesting result because it's a highly optimized ClojureScript code in which we already made a lot of optimizations and a lot of kind of removing of repetition of boilerplate by using macros and DSLs, which means that, asking the previous question from the previous presentation, in JavaScript it will be probably in a ballpark of like 500,000 lines of code, like my wild guess. The most important metric, we're not talking about the application that is being used for a couple of people. It's actually being used by almost more than 300 customers across the world, and every customer has a data center, which means that our application is being used and viewed by people who manage thousands and tens of thousands of networking devices. So you can imagine the scale of a single deployment. And our biggest deployment was 400 racks in a single data center. So multiplied by 48 nodes in each rack, 2 switches on the top, aggregation switches, spines, leaves, and you will get the idea. So how we get there? It all started in 2014. Apstra was founded as a startup, and it was founded by people who came from like networking companies with networking backgrounds, which means that at the beginning, they have been mostly concerned, like engineering team and founders have been mostly concerned about finding the proper data modeling and find the proper architecture that will scale to the needs of the backend. So the UI has been almost added as the afterthought. And at the beginning, we actually have 0 people with proper web application development experience. So I volunteered myself to do the research and build the initial prototype. And I spent a couple of weeks exploring the JavaScript land and failed because there was around like 40,000 tutorials saying that this is the framework that you need to use, and this will give you the success. So I don't trust this kind of size of the ecosystem. I looked at the ClojureScript land because I had prior experience using Clojure on the pet projects and realized that this is a golden opportunity to actually use it in production. And I implemented like a simple prototype using Reagent with a couple of screens. We have shown the first demo to the customer, and our CTO said that he doesn't care about the technology of choice as soon as we can keep up with the pace of development of the backend, which sealed the deal. And this is how I became a ClojureScript developer for the next 9 years. Next, we have been rushing towards version 1.0 for 2 years. And at this stage, we had to introduce some structure to the code, as well as to use some of the best practices available back to the days in the industry, which was to migrate our atoms from all of the application to the single state management system, which was Reframe. Extend the team with at least 1 more additional ClojureScript developer to reduce to increase bus factor. And we also added a JavaScript developer just to keep all of our visualizations separate and maintained by the people who know how to do visualization. Next, after we released version 1.0, we've got a set of initial customers that basically barraged us with a bunch of requirements. So we started to become a feature factory by building like dozens of features per release. And when we have been doing these features, we started to realize which kind of patterns we see in a code base and what kind of internal frameworks we need to introduce in order to kind of reduce the boilerplate and make creation of new features as effective as we could do with our given team. Speaking of the team, since we have been in production doing real software, we had to extend team beyond the development. So we added people who have been doing the automated Selenium testing for all of the UI, so we can safely change the things, as well as build engineers who will provide us CI/CD and proper code organization and proper code delivery for the final product. Finally, 2 years ago, we have been acquired by Juniper Networks. That's why I painted my presentation in Juniper-like colors. And this acquisition actually brought a lot of new challenges. So first of all, our customer base has exploded. And we started to see customers that we've never seen before that gave us a lot of interesting use cases. So we continued to develop features. But in addition to that, if you want to be a good citizen of a company that has acquired you, you have to integrate with a lot of things like internal proprietary support systems, documentation system, escalation system, etc. So right now, we are still in the process of kind of being fully integrated in Juniper. But this is an exciting journey because it continues. Like right now, initially we have been like fighting for survival, then fighting for acceptance, and now we're fighting for like scale. And I wouldn't say worldwide domination, like some domination. Okay, let's talk about the technological aspect. So we use Reagent, which means that we pretty much in this data loop that Reagent advertises as the solution to data state management problem. So in a reframe database, we keep almost everything, API responses that we fetch it from the backends, form state, metadata, session info, and so on and so forth. We subscribe to this data to render Reagent views, and we use events in order to update the state in the database and re-render the views. But one of the most important events is actually not directly user-triggered. It's a navigation event. So at the early stages of our application, we decided that we will have state of the application being mostly determined by what current route you have. So whatever user entered in a router, in a browser web console, that he needs to see like the results and everything associated with the router. So here is a small example. If I want to render a table of rack types, it means for the application itself, then when user navigates to this route, there should be several steps happening. We need to check permissions, we need to fetch required data, we need to pick a component that needs to be rendered, and we need to do some of the rudimentary things, like, for example, update information for the breadcrumbs. So this kind of definition pretty much screams for using Clojure map. So we decided to create our own route map, because back to the day there were no available like decent routers on the client side. And everyone can create their own route map. It's pretty straightforward. You can create a map in which the key will be your, well, you can use a route token directly as a key, or you can use namespaced keyword, and it will be easier to get the auto-completion and uniqueness of routes. And you can define everything that you need to do in order to render the screen. You need to define which view needs to be selected, which events needs to be initiated, and so on. And this onNavigate event that is basically initiated when you load the application will be doing a simple thing. It will be just processing this route map, finding appropriate metadata entry, and just doing the right stuff with appropriate keys. Now, this approach is scalable in 2 dimensions. First, you can actually extend any single route map pretty easily by adding new route map entries. But it also means that you can create an application which will be split into multiple files. And eventually, since we're using just a map for the routes, you can load all of these files in one place and just merge these maps using Clojure merge. And all of a sudden, you have the definition for all of the routes that you have in your system. This is how I calculated like 392 routes. I just made a count of keys in this particular map on our application. The problem with kind of defining routes is that it's easy when you start with it, but then there are more complex routes that you encounter in your application. Here is an example in which we need to render LLDP telemetry for a single selected device. And in order to do that, we actually need to perform several actions in a sequence in which previous action depends on the result of next action depends on the result of a previous step. So, first thing that we need to do, we need to fetch information about device itself. And if there is no device, we cannot render anything else. We just need to render 404, which means that the only UI part that actually depends on the result of the data fetching is breadcrumbs and the top level menu. You cannot do anything else. And you check permissions at this level as well. If you succeeded at this step, the next step would be to fetch information about telemetry for this particular device and see if LLDP is enabled and working correctly. This step will also not render you the information about telemetry. It will just render you the secondary menu with the states of the telemetry labels. And only at the third step, you can actually start polling for telemetry data in order to render this table. So, long story short, most of the screens that we use in our application have a very kind of sophisticated data needs that needs to be fetched in batches, and you need to pretty much define what and how you render depending on the results of every step of the execution. Now, how we can solve this with route map? Well, the solution is pretty obvious, because when you use a map, you can use a map to describe any kind of a data structure. And when you have these dependencies in your routes, you pretty much can create a reference key in your map that will be pointing to another route through this map. In this case, the on-navigate event and understanding what needs to happen and when becomes a traversal exercise from your bottommost points all the way up to the termination point to decide what you do. And in order to kind of explain it from the code perspective, here is a kind of simple solution. So we create a key, related routes, and when we can define keys that will tell us which route is a parent route for this particular task. And we can create relationships for rendering views components, initiating events, and doing some other stuff. In this case, our route map also becomes a tree. Well, you can actually make cycles in this graph if you want to, but in this case, your traversal will be infinite. So we want to be able to terminate at the topmost points. So if I want to trigger events, again, I rely on this reference key, and then I just kind of traverse and verify all of the on-enter events. There is one catch here. In order for me to execute events that require result of a previous execution, we need to save some state in a database and have some check mark that we can validate as a predicate. So some of the events might not be executed because you received 404 in the previous state. This kind of approach solves a lot of interesting challenges from the technical side, almost by accident. First, imagine the situation when you have two screens and they share some data needs. One screen requires 10 different API endpoints, second one requires 7, and they have intersection of 5 different API endpoints. If you have this definition provided on the route map, you can basically traverse your route map during the on-navigation event and compute set of API endpoints that you need on route A, set of endpoints that you need on route B, and do the set difference. When you do the set difference, whatever is not in a set from first page will be deleted, and whatever is not there will be fetched additionally. So this is how you optimize unnecessary data fetching when you jump between the routes. Same is true for polling intervals. If you have polling intervals on screen 1 and screen 2, you don't want to restart all of the polling intervals when you navigate. If you're already polling for something, you want to keep this interval just because you don't want to rush data to be arrived, which means that you can do the same set difference logic in order to understand what needs to be fetched additionally. Same mechanics actually works for views. You saw this approach when we only render the top navigation menu, secondary menu, and the component itself. Well, I would say that you can create a relationship in your route map that allows you to say that here's my termination point, and it will be my top level container. Then I'll have another container, and then I will have a view. And you can basically traverse it using simple loop in a Clojure recursively, and eventually wrap up all of your views with additional containers. So, to summarize, we had to create our own router because we started to see these patterns that require some complex data management and data fetching from the backend, as well as kind of some state machine of triggering of different events. And for us, it became an exercise of how we keep our route map as dry as possible to avoid any repetition. We don't want to create the kind of scaffold of the same type of components that we render. We just want to make sure that our routes point to the right direction. Next, views and containers. So I mentioned a little bit about containers before, but just to define them, container is a component that can take another component as an argument. And the simplest container will be just a layout container. For example, if you have a grid system and you want to render everything in the middle, you can just create a simple layout and have a component passed as an argument and rendered inside. In this case, containers are very usable because you can actually wrap a single view with multiple containers. For example, you have navigation menus, you have actions, you have breadcrumbs. You can all consider this as Russian doll pattern in which you add more and more containers and just wrap your final view. You can create navigation containers, which will be a bit more sophisticated example. So you can create, like, in the middle, you see the usage. So we can say that our container will have like a title and component that needs to be rendered when this menu element is selected. Then you have a simple processing on the container side, on the definition, that will determine how to render active tab and how to select appropriate view. And in this case, like on the right side, you will see the, on the right side, yes, you will see the result of this execution. This allows us to create navigation containers and keep all of the menus and navigation logic in one place while styling it like many different ways. Finally, we're still old-fashionedly using all the React and React lifecycle methods. And this is actually sometimes also quite useful if you need to perform some kind of an ad hoc event dispatch when you don't rely on your route map. For example, if you want to fetch a data when you open a model and you want to kind of rely on the component, you can create a container that dispatches all of the required API calls, fetching, and only renders your component when data has arrived. This is very useful when you do like the models in which you need to show the spinner that waits for 7 different API responses. So to summarize, containers are a very usable thing for us to reduce the boilerplate, primarily because they are ultimately composable. You can literally use com function from Clojure and use multiple containers as soon as they have the same function signature. And we can parameterize them. You can actually create a bunch of partials. You can keep your logic in container itself, and you can create parameters that will tell you how to parameterize this container. And you'll just create a bunch of partials that you can reuse in different aspects, like primary menu, secondary menu, right menu, left menu, bottom menu, whatever. Forms. So this is a very interesting beast, because since we're sitting on top of a REST-like API, our form is technically, like when we create a form, we technically get an API that will be submitting using post or put request. And in this API, you will see a data definition that will say, I expect this kind of a payload. So this is the first aspect. Second aspect, technically form is a visual editor for this payload. Like whatever components you select, either like text inputs or radio buttons, you basically find the component that will be most applicable for the data type that you modify, and you can reuse those components. So for example, if you have like a small enum in your API, you can create either radio buttons or drop-downs to select the value. And the third aspect is lifecycle for form itself. Form, when you first initialize, like in a pristine state, but you want to make sure that you submit form, you actually log the submit button and you log all of the controls. You want to make sure that when you get validation errors, you actually show and highlight only the fields that have these validation errors. An important aspect is that if we have so many forms across the product, they all should behave consistently, which means that we want to implement this life cycle once for all of the forms. Let's see how we can do it with Clojure. So to cover first aspect, data definition. Whatever we get in our Swagger documentation is directly translatable to any Clojure data definition library. We use ClojureSpec, and we use it extensively because we can describe any field and we can reuse any field. And ClojureSpec maintains for us the global registry, which means that for our data model, we can actually reuse definitions across the land. And if we want to describe the payload itself, we can just use S keys to say what kind of payload and which kind of keys will be available. And even if you have like a very complex APIs that have some conditional payloads, you can use the multi-spec in order to satisfy these APIs. Now, regarding data modeling, we have a lot of forms, and in this, it means that we don't want to reuse definitions for standard things. In the networking domain, you will see a bunch of forms that will use standard things like IP address, VLAN ID, ASN number, what's not. Which means that we can move all of these definitions into some common namespace, and when we assemble the form, we just can drag all of the required definitions from the common place without rewriting them again. So if we want to cover the second aspect, we need to build some minimalistic framework for reframe and spec. And this framework can be literally done on one screen. I actually written an article probably 4 years ago, and it's still relevant. So you can have a simple place in a database in which you store your form state, and if you have a single event that modifies this state. Second, if you want to create a UI component for that, you just kind of find the onChange method that properly finds which field to update and how this component dispatches the data. And you can add the validation by saying that on every change, I will be run validation of ClojureScript, and if data is not valid, I will just show the error message. Finally, if you don't want to write this boilerplate all of the time, you just extract this as a single function that accepts everything that's about this form, like form key, field pass, etc. Which means that your form definition becomes like a one-liner saying that I want to use this component in order to, and this spec, in order to render this field. Finally, to cover the third aspect, the lifecycle, we can basically rely on our trustworthy containers because we can rely on their lifecycle as well. So if we have this kind of form lifecycle in which we don't want to show errors immediately, but only after first unsuccessful submission, we can create this container. And important aspects of this container is that we rely on React lifecycle methods to do the setup and tear down for the form. But we also rely on a component that is passed to this container to be the form view. And the rest of the form is just your standard model with the title and the button, which means that we can control the button and its state and control the form by sharing the same form key. This allows us to write this container once and reuse it multiple times. As I said, 192 usages across our code base, all forms behave exactly the same. And as I said, bringing it all together, creating a new form, you define a spec specifically for this payload, you create a form view, and you initialize the component that uses this container with some init data. That's it. Collections. So this is something that I have rewritten like 4 or 5 times before getting it right. Probably 6 years ago, I open sourced a reframe data table that I've deleted after writing it second time and third time. But the important part is that collection has 2 aspects to it. One is how you manipulate the data. So you have to have some controls for the data that you show to the customer, to the user. And since typical operations on collection require sorting, pagination, and search, you can actually do it using standard Clojure functions and do not invent the bicycle. And you can just do it in a subscription, which means that if we have a subscription that knows how to perform standard manipulations and encapsulate this logic in this subscription, we're pretty much done with this aspect of collections. Second aspect is that you can have multiple representations of the same collection. You can have data tables, you can have card views, you can have list views, but independent of what kind of representation you have, you still want to be able to sort, paginate, and search. So if you want to do this for collections, like our last invention that has been around for 5 years, is that we define collection in terms of fields that you get in API GET payloads. For example, if you want to define a simple collection of nodes that have name and that have role, we can have a collection definitions will say that I know that there will be a field called label, and I know how to extract the value for this field because it can be a deeply nested field. And then all I need to do is I need to have some kind of a DSL that defines this particular collection entry to know how to process this. So for example, if I define a comparator, it means that if I know how to compare 2 elements by label, I can actually render sorting errors in my table view. Same is true for search. If I know how to index elements and search match elements in this index, I can actually implement search, and I can even generate a search component that will know how to do that. For example, if you do set and contains, it naturally goes to, and your kind of data set is small, you can automatically create a search dropdown and just say, I want to filter by this particular role. If you want to render this table, it's also actually quite trivial. You create a wrapper component that does the following. It takes collections definitions And in order to render header, it just go over collection definition field by field and render header title. And if it's sortable, just render the sortable element. If you want to render elements, you render one row for each entry, for each item, and you again go over every column definition and render corresponding cells in your table, using the same mechanism as you used in header. And kind of to summarize on collections, again, we have been using them quite a lot, and we're not very lucky to have backend helping us with collections, so we have to provide additional information, like, for example, partial selection, like filtering on collections that have thousands of elements, don't tell anyone, etc. Lessons learned. First, let's talk about kind of how we were able to maintain this code base and do not panic. Well, first, this is not specific for Clojure, but it has special flavor in Clojure. When you maintain such a large code base, conventions are very important. And specifically for Clojure, conventions are crucial because Clojure is such a powerful language in which everyone can write code slightly differently. And if you create a pull request and you see something that you've never seen before, somebody has finally decided to use treesec, then you pretty much need to understand how to normalize this behavior. Which means that for us, it was important to structure the code consistently for all of the applications, for all of the sub-applications that we merge in the single application. Be consistent with names, be consistent with which features of language we use, try to avoid macros at any cost. And in this case, pull request review becomes a review if you match convention or not. Second, for us it's ClojureSpec, but right now there are a lot of new cool kids in town. But technically, what you want to do for such a large code base is to have your whole domain model defined in some kind of data definition form. We have written specs for everything that our API provides, and we compose the specs for forms, but also we use the specs for the get data. So if there is a malformed data coming from the backend, we can catch it by knowing that it didn't conform the spec. It's also important that it's very easy to overuse these data validation tools and start to invent your own some kind of a dynamic type system. So in order to avoid that, just use it on the boundaries of your system. For us, the boundary is where we speak with the API. As soon as we know that the data passed the API, we know how it looks internally. So all the way up to the view, we don't need to spec intermediate results. Next, use namespace keywords. This is my personal preference. I'm too dumb to use text editors. I use IDE. And namespace keywords allow you to do two things. First of all, you don't accidentally create like new keys that do the same thing. And second, your IDE loves them. You can jump to any definition and make sure that you know the semantic of this definition. Finally, if you do things like we do, frameworks, DSLs, etc., keep them small and keep them well documented. And since we're in a Clojure world, the best documentation for the framework is to have a spec for its argument for every function and have a spec for every entry in your DSL map. And it's also important that you do not get stuck like with a single solution forever. You just periodically rewrite your frameworks to the new things. After previous presentation, I actually want to kind of try some of the things that appeared lately. Hiring and team management. So this is a controversial topic, but for us it was surprisingly easy. So hiring appeared to be not such a big problem because for two reasons. You get a smaller pool of candidates, but generally you get a higher quality candidates because people who have invested into learning Clojure, they either kind of come to it understanding the limitations of their previous experience or want to self-educate themselves. Which means that instead of like browsing through hundreds of resumes of standard JavaScript developers that completed like a React tutorial, I can actually find a person who had some even like toy project experience with ClojureScript, and I will be sure that he will be more or less applicable for the team. And we also learned that people will be actually willing to switch domains in order to use their favorite toy in production and get paid for it. Our first hire for ClojureScript position was a guy who was a Java developer who never done front end, but he was excited to use Clojure somewhere, and ClojureScript was his destination. Finally, since we also have a team that has a JavaScript component, we do not force Clojure on everyone. We just show how it works and if it benefits them, and let them decide. If you like some technology, don't force it on others. Just sell it. Onboarding team members. It's very important to make sure that you hire a new person and he is productive. But you don't need to make him productive immediately. What we do for the onboarding, we take a new person, and I personally spend a week with this person, 2 to 3 hours per programming, just to make sure that he completed the proper onboarding. And instead of throwing them to write a new feature, we actually have a lot of features already, so we can easily rewrite one of the features and see that person is ready. If a person can write a rewrite existing feature using route map, using forms, using collections, using all of the conventions, and created a pull request that makes sense, it means that I can assign a new feature to him or her. So, conclusion. We build the technology, well, we use the technology. We used ClojureScript for the domain where this technology worked. We knew that on a client side, we'll have to do a lot of data manipulation and data stitching in order to render this UI. So ClojureScript worked for us. But this is not enough. You actually need to have a team of like-minded people who will support you and who will provide like additional inputs in terms of how you want to build your code base. You cannot kind of be the only pioneer of this technology in order to succeed. But this is not enough. If you want your application and company to succeed, you need to make sure that whatever you build has some kind of a market fit. And to be honest, we have been struggling for a couple of years before we found what we actually are doing. And it would be very frustrating to build like such a large code base and just make another entry into non-Google graveyard of applications. And finally, this all doesn't make sense if you don't have enough luck. So we got lucky, and I'm telling you our experience report, which is more or less a success story, how we build a company and sell it to Juniper networks. But as a conclusion, I want to say the following. I wish all of you in this room to be able to find a domain in which your favorite toy, at this point Clojure, will be applicable. I wish you all to find or build a team of like-minded people that will help you to grow your application to the perfection. I wish you all to find your application market fit, and I wish you all luck. Thank you.